Hi everybody, welcome back. We're so glad to have you back in our second class of this specialization. So let's talk about the big data Hadoop stack. So far we have talked about basic concepts needed to understand big data from both technical and business side. However, in this class we're going to spend a lot more time on diving deeper into the technical issues and truly understanding how does a Hadoop stack work. What does the architecture look like, and what kinds of things can we do with this framework? So just as a reminder, we talked a little bit about the Hadoop, but let's talk about what Hadoop is. It's an Apache open source software framework for storage and large-scale processing of the datasets and clusters on commodity hardware. It is licensed under the Apache license, and it's open source, and we're all free to use it. So Hadoop was created by Doug Cutting and Mike Caffarella in 2005. That's a long time ago. It was originally developed to support distribution of the Notch search engine project. Doug, who was working at Yahoo at the time, who is now actually a chief architect at Cloudera, has named this project after his son's elephant, Hadoop. I've found out recently that you're supposed to accent the front of the word, Hadoop. Anyhow, his son called his elephant Hadoop, and Doug used this name to name the project after him. So let's look at what makes Hadoop so interesting, so scalable, and so usable. If you think about it, Hadoop, it started out as a simple batch processing framework. MapReduce allows people to perform computations of big data sets, computations we can't easily perform without this kind of architecture. It's a very simple but powerful computing framework. It is very efficient. The idea behind Hadoop is that instead of moving data to computation, we move computation to data. Hadoop MapReduce provides a shared and integrated foundation where we can bring additional tools and build up this framework to do all kinds of cool things, as we will see in this class. Now, we talked about scalability many times in the previous class. Just keep in mind, scalability is at its core of a Hadoop system. We have cheap compute and storage we can distribute and scale across very easily in a very cost-effective manner. All of the modules in Hadoop are designed with a fundamental assumption that hardware fails. Unfortunately, that is true. If we think about an individual machine or rack of machines or a large cluster or supercomputer, they all fail at some point of time, or some of their components will fail. These failures are so common that we have to account for them ahead of the time. And all of these are actually handled within the Hadoop framework system. So the Apache's Hadoop MapReduce and HDFS components were originally derived from the Google's MapReduce and Google's file system. Another very interesting thing that Hadoop brings is a new approach to data. A new approach is we can keep all of the data that we have, and we can take that data and analyze it in a new interesting ways. We can do something that's called schema on read style. So I can read the data and create the schema as I'm reading, instead of spending hours and days and months creating the schema, trying to fit the data within the schema I've created earlier, like we did in the old days. Now we can afford to keep all of the data in a rough format and then project it into the schema on the fly as we're reading it in. And we can actually allow new analysis. We can bring more data and do simple algorithms, which has shown that with more granularity, you can actually achieve often better results than taking a small amount of data and doing some really complex analytics on it.